Hey everyone, here's a short video on binomial expansions. So let's say we have something like this, 10 plus 1 squared. It would be nice if we could just say it's 10 squared plus 1 squared. But let's see if that really works. 10 plus 1 is 11, 11 squared is 121. Meanwhile, 10 squared is 100, 1 squared is 1, and that is 101. Obviously, these two things are not equal to each other. So something else is going on here that we've got to account for. What happens when we do 10 plus 1 squared? It's the same thing as saying 11 squared, which is 11 times 11. We can think of this as an area problem. This is 11 by 11. But let's break this up into different regions. Let's break this up into a shape that is 10 and 1 and 10 and 1. Now, just like before, it's still 11 by 11, but now we have these different regions. Now, this region is 10 squared, which is what we have here. This region right here is 1 squared, which is what we have here. But we also have these other two regions that we didn't account for. We have a 10 and a 10, and if we add those up together, then we do get our 121. So then these guys would be equal. Now, same thing's going to happen if we just change those letters and we call this x plus 1 squared. As tempting as it might be, we cannot say this is x squared plus 1 squared. That's not going to be the case. Let's look at this as an area problem and multiply it out. And we will get this region x squared. We will get this region 1 squared. We also have this region 1 times x will be 1x, which is right x. Also, this is 1 by x, so we're going to call this side 1x too. So that's going to turn into x squared plus 2x plus 1. Now, instead of using the box method, we can also get the same answer by using the distributive property. So this x is going to hit both of those terms. When it hits the first term, x times x, that'll be x squared. When it hits the second one, x times 1 will be 1x. And if I work underneath here, then 1 times x is another 1x, and then this is a 1. Combining like terms, that's going to give us x squared plus 2x plus 1. Now, what if we took this a step further and we had x plus 1 cubed? Now, again, like I said before, we can't say it's x cubed plus 1 cubed. And the reason why we can't is now we have a three-dimensional figure. And if I try to break this up, and this is really going to test my artistic abilities here, then that is going to be, we will get an x cubed. This region right here is x cubed. This region right here is 1 cubed, but you have all of these other regions inside of it, and they're kind of tricky. So instead of thinking about it geometrically, let's just follow what we know. X plus 1 cubed is x plus 1 times x plus 1 times x plus 1. Now, we can't multiply these all at the same time. We're going to simplify this part, and then we'll go forward. Now, if you remember from earlier in the video, if we multiply all those things, that's going to give us x squared plus 2x plus 1. And then we've still got to go back, though, and multiply it by the x plus 1. So we get the arrows, and we hit that one and that one. So x squared times x is x cubed plus x squared. X squared hits x, and it makes x cubed. X squared multiplies by 1 and gets x squared. Now, this x squared has been used up. I'm going to cross it out. We're going to now use this 2x. So 2x times x is going to be 2x squared. And now it's going to hit this, and it's going to be 2x. And now let's go in with this one. We've used that guy up, so this one's been used up. And now let's use this last term. 1 is going to hit this, is going to be 1x, and it's going to hit this, it's going to be 1. And if we combine all of those like terms together, we end up with x cubed. These guys combine to be 3x squared. These guys combine to be 3x, and these guys combine to be 1. So now what if we had x plus 1 to the 4th? Well, that's x plus 1 times x plus 1 times x plus 1 times x plus 1. So again, we can't do these all at once. We're going to look at this chunk, and we just found out that that chunk is going to be x cubed plus 3x squared plus 3x plus 1, and we're going to multiply it by x plus 1. And you can tell that this is going to be a lot of work. So that's going to hit that. And I'm going to just stop talking for a second. I'm just going to do this. So once we combine like terms, we have x to the 4th plus 4x cubed plus 6x squared plus 3x plus 1. So you can imagine if we have something like this, x plus 1 to the 23rd, what is that going to look like? Well, we can definitely say it's not going to be x to the 23rd plus 1 to the 23rd. In fact, we know it's going to be some huge thing with lots of terms, and it would take us a long time to figure out. So the next class is about a shortcut. How can we find the solution to this binomial expansion with a tricky little shortcut that'll avoid all the pain of multiplying out all the layers above it? Okay, thanks for watching.